This problem is going to be example number 6 of the different types of probability problems that we are solving and posting on YouTube from digital-university.org. One thing we want to point out to you is that for a lot of the probability problems that we're going to encounter, we use the math techniques that we had discussed in previous videos, particularly dealing with different types of permutation problems. We posted like 10 videos there, and also different types of combination problems. We posted a whole series of videos. And quite often in the probability videos, we draw upon that background. So if you hear us making a reference to a previous video or a math technique that you're not familiar with, go to the website, please, and then click on Combinatorics and Probability section, and you can find those earlier videos. Okay, in this one, we have a problem that states a box has 20 transistors, 5 of them are defective, and an inspector examines the contents of the box. He takes out one transistor, examines it for defects, and places it back into the box. Then later, a second examiner comes along and does the same thing. So when the first examiner is finished, he puts the transistor back in the box. So the box still has 20 transistors with 5 defective ones. When the second examiner comes along, he does the same thing. He examines one transistor for a defect, and whether it's defective or not, he returns it to the box. And a third examiner does the same thing, removes a single transistor, examines it for defects, and places it back inside the box again. So the question is, what is the probability that at least, and the key phrase here is at least, one of the examiners finds a defective transistor? So our problem can be sort of summarized like this, if we can get this into focus now. Okay, event E1, that's the event where the first inspector finds a defective transistor. Now the complementary event, E1C, that would be then where the first inspector does not find the defective transistor. And then E2, that's the event where a second inspector finds a defective transistor. Or the complementary event again would be the second inspector does not find a defective transistor. The third event that we designate as E3 is where the third inspector finds a defective transistor. The complementary event E3C would be where the third inspector finds a non-defective transistor. And notice that the probability of either the first, the second, or the third examiner to find a defective transistor is 1/4. Remember what happens. The first examiner comes along, removes a transistor, examines it, then puts it back inside the box. So you still have a box of 20 transistors, 5 of them are defective when the second examiner comes along. Same thing when the third examiner comes along. So in each case, the probability for an examiner to find a defective transistor is 1/4, or to find a non-defective transistor in each case is 3/4. Okay, and again, our question is, what is the probability that at least one of the examiners will find a defective transistor? So let's consider it like this. We can have, if one examiner finds a defective transistor, and only one examiner, then of course only one defective transistor is found. So that's a possibility. Or 2 examiners might find a defective transistor. So then that would mean then that 2 defective transistors would be found. Or all 3 examiners might find a defective transistor, in which case 3 defective transistors would be discovered. Or it's possible that all 3 examiners might find a non-defective transistor, in which case 0 defective transistors would be detected. So those are all the possibilities right there. Now, the probability of this, of detecting 1 transistor, plus the probability of detecting 2 transistors, plus the probability of detecting 3 transistors, we'll rewrite this, plus the probability of detecting 0 transistors, those have to add up to equal 1. All the possibilities, the probabilities of all those always have to sum to the numeral 1. Okay, what could we, perhaps it might be easiest to answer this question. What would be the probability of this one? All 3 inspectors find 0 transistors. So this would mean then we would have, or 0 defective transistors. So here, that would mean the first inspector does not find a defective transistor. The second inspector does not find a defective transistor. And the third inspector does not find a defective transistor. Okay, what's the probability of that happening? These are all independent events now, so the probability of this happening is equal to the probability of this event, E1C, times, like we did in the previous videos, when we have these independent events. Here we have the first inspector finds no defective transistors, and the second inspector finds no defective transistors, and the third inspector finds no defective transistors. The probability of that happening is the probability of this event happening times the probability of this event happening, times the probability of this event. And again, it's like this because all these are independent events. If the first inspector does not find a defective transistor, that has no bearing on what the second inspector might find or what the third inspector might find. So all of these are completely independent events. Okay, and as we just noted, the probability of each one of these is the same. It's 3/4. The box has 20 transistors, 5 of them are defective, so the probability of each time of finding a defective transistor is 5 out of 20, or 1/4. Then the probability of finding a non-defective transistor is 1 minus 1/4, or 3/4. So this is just equal to 3/4 times 3/4 times 3/4 equals 27 divided by 64. So that would be the probability of all 3 inspectors finding 0 defective transistors. And that's what this is. 0 defective transistors are found. Now, let's bring this over to this side of the equation. So we have 1 minus the probability where 0 defective transistors are detected, which is this right here. We just figured it out. that is equal to the probability where one defective transistor is found plus the probability where two defective transistors are found. This means that one inspector found a defective transistor. Here, two inspectors found a defective transistor, or perhaps all three inspectors will find a defective transistor. So that means three defective transistors are found. Well, look at this closely now. This is 64 over 64. (64 minus 27 is 37. So we have 37 over 64. That is the probability of at least one defective transistor being found, or at least one inspector finding a defective transistor. It's the sum, really, of finding one, or two, or three. Remember, the problem stated at least one defective transistor. What is the probability of that? And that would be this number right here. This includes the sum of all the possibilities, including just one. So this would be the probability then of detecting at least one defective transistor. Now, if you're not completely convinced that this is the correct answer, let's then do this. Let's ask ourselves, well, what would be the probability of detecting three defective transistors? And figure this out individually. And figure this one out individually. And figure this one out individually. We'll do that. Please bear with us. Your hope will be worth your while for us to do this. In order to achieve it, we might have to split this video into two portions. But let's go to here. And we want to consider the probability of all three inspectors to detect a defective transistor. So what are we talking about? E1, that's the event where the first inspector detects a defective transistor, and the second inspector also detects a defective transistor, and the third one does. Okay, these are all independent events. What is the probability of this happening? And of course, that's equal to the probability of V1 times the probability of V2 times the probability of E3. And in each case, this is 1/4, this is 1/4, this is 1/4, so we have 1/4 cubed, or that equals 1 out of 64. So the probability of all three inspectors detecting a defective transistor is 1 out of 64. Okay, now we have two more possibilities like this then. Now we have to consider the probability of 2 inspectors. Detecting a defective transistor. Now, how can this happen? Well, let's see. The first inspector might detect one, so that would be event E1. The second inspector might, so that would be event E2, and the third inspector might not. That would be E3, complementary. That's one way. Or it might be the first inspector detects a defective transistor, but the second inspector does not. And the third one does. Again, 2 defective transistors are found. It could happen like that. Or, we'll try to keep things in focus. It might be that the first inspector may not find the defective transistors, but the rest of them do. The second one does, and the third one does. Okay, now remember, when we have these kinds of situations where here's an event, or this event, or it could be this event, the way that that is designated, put parentheses here, put parentheses here, and then we have this. That's how that is designated. And for this one, put parentheses here. There, that's how we designate it. Now we want to know what is the probability of this happening. So that would be the probability of this event happening, the probability of this event happening, and the probability of this event happening. So we have 3 different events here. 3 different events. This one, and this one. Not only are they different events, but they're mutually exclusive. This one says the third inspector does not find a defective transistor. Here the second one does not find a defective transistor. Here the first one does not find a defective transistor. See if we can keep these in focus better. So, by nature, all these are mutually exclusive events. Okay, so that means then that the probability of this happening is the sum of these. Is the sum of this plus the sum of this one plus the sum of this one. That's how it works for mutually exclusive events, as we pointed out in the previous videos. Now, before we actually do that, let's consider what would this be right here. Here we have independent event E1 and independent event E2 and independent event E3C. And the probability of that happening is the probability of E1 happening times the probability of E2 happening times the probability of E3 happening. And I think we're going to have to stop the video at this point. We're going to break this into 2 parts. Come back, join us in the next video. We'll finish answering this question, and then also we'll determine the probability where only one inspector finds a defective transistor. Come back, join us in the next video, and let's get this problem finished.